Welcome back to what it takes to implement the C++ standard library. Where we left off last time, we were talking about how the standard library depends on compiler extensions, and that we should be building as many things with the changes that we've made as possible. That we should be following best practices at all times. That we should be consulting the standard directly, not that we shouldn't be using CPP reference. Very important distinction to make. And that we need to persevere. Are there any questions about any of that? I see none. So, you're probably also left wondering, how do I contribute? Now, I realize this should probably have said yesterday at this point, but you're probably wondering, based on the topics of yesterday, how do I get started with actually contributing to an existing project? There are 3 major implementations, and while I talked about them yesterday, I didn't actually go into any detail on what you can do to get started with contributing to one of the implementations. So we're going to spend some time putting something into libc++. Now, is there anyone in the room who would like a quick refresher on what libc++ is? Okay, so just in case, libc++ is an implementation of the C++ standard library that's shipped by the LLVM project. LLVM is a toolchain vendor, and it's an open source project that we can contribute to, and it is responsible for also vending Clang, which you are probably familiar with. Today, we are going to implement ranges fold right. We're going to go through what a few folds are, and then we'll then look into implementing it in libc++. So, a fold is essentially condensing a series of elements in a range into a single value. We had std accumulate back in C++ 98 and has lived with us forever. In C++ 17, I think it is, we got std reduce, and then in C++ 23, we got fold left. We'll talk about that in a second. So a key thing to note here is that std accumulate takes a range and a value, and that is the same as also passing in the plus operation by default. We can then turn this into fold left with ranges. I use the namespace alias std_r to go to refer to std ranges, because that is a very long namespace, and it will produce the exact same result. But a fold left will also take into account the fact that if the result of the plus operation is different from the value that you pass in at the start, it will change the type to match that. And there's also a range-based overload. And so then there's this, the way this works is that it will add 43 to 648 to 49 to 88 to 110 and so on through to 56. And that's why we call it a left fold, because it works from left to right. So you might be wondering, well, if we pass in minus, what's the value going to be? Well, it's the same, but through subtraction. And if you're now wondering, well, how do we get from right to left? Can we just pass in a reverse? The answer is that the result is still going to be the same, even with minus, which actually kind of surprised me as I was building these slides. I did expect it to produce a different result. The difference between fold left and fold right is that it will flip the order in which the operations have, and for the purposes of subtraction, it will also invert what the second parameter is. So let's go ahead and implement that in libc++. So to do that, we would need to get started with working out what the LLVM project is, and then learning a little bit about the project. So if you want to get to get libc++, you have to do that by downloading the LLVM project, which is available on GitHub. And if you've heard that the LLVM doesn't take contributions through GitHub, well, they have for them, I think, the past 9 or 10 months. Things have been moved into GitHub, and so making pull requests and filing bugs is all done through this GitHub link. Then there's the documentation for libc++, which is very comprehensive in terms of how you can get started and what the conventions are. There's status pages so you can see what you can contribute. And then there's documentation for a range of things such as the hardening modes that I was talking about yesterday and what implementation defined behavior we have. And then finally, I mentioned that we should only be consulting the C++ standard for implementing and reviewing things. And so we would go to this eal.is/C++ draft, the link. And then this named alg.fold is the index for the fold algorithm in the standard. And so that's what I've got open here. The reason that I had it pre-opened is mostly because this section is pretty big and finding fold right is fairly difficult to do. So that's the theoretical component of this done. Before I get started, are there any questions? I see no questions. Fantastic. Okay. So what we're going to do now is we're going to open up libc++, which is this project that I've got in Visual Studio Code at the moment. And we are, sorry, not CMake. We are going to go ahead and implement it. This is a fresh checkout of LLVM project. So I haven't got any alterations so far. And so let's start by opening up the libc++ directory. All right, and we're gonna start, because I said yesterday that we should be doing test-driven development. We're gonna start by adding some tests. And so what we do is we look for the alg.fold directory that is found inside the test directory. Oh, sorry, I should note, if you have questions or you feel like I've made some sort of assumption that isn't clear to you, please interrupt me immediately and let me know that you have a question. That is something that you're allowed to do. So that will be found in the algorithms directory. And then I believe that is also under the non-modifying directory, and we can find the alg.fold directory. So we can see that there is also a leftfold.parse.cpp. So that means that leftfold has already been implemented in libc++, but the fold right algorithm has not been implemented in the project just yet. And so we're going to make a new file. We're going to call it, I guess, right folds. And so now what we will do is we will just open up the left folds folder file, and let's copy all of this. Typically, when I am working on libc++, I will just open up the nearest file and copy the headers there. I will go through what that all means in a bit. Most important headers are the algorithm header, which is where we're going to source the fold right from. The cassert header, which is where we're going to source assert from, and the test macros header. Those are all the interesting things at the moment. So what we're going to do is we're going to create a main function. And for reasons that I don't fully understand, that we have some platforms that we support that require us to not only take in the int and char star array parameters, but we also have to explicitly return 0. And then what we're going to do is we're going to have a test function. And we will call test inside main. And then once we get to the const_express section of fold right, we would add a static assert and change that to bool. Tristan's talk from earlier had a similar mechanism in it for flux, and that was actually a pretty similar thing to what libc++ does as well.
I didn't know that.
You didn't? No, fair enough. And now we'll do test empty range. So let's create that. And in here, what we're going to do is we're going to create a vector. I think it might be better if I turn off clang D. Nope, I can't do that. Okay, so let's just create an empty range of an empty vector, and we will then go ahead and test that. So we'll do stirred ranges fold right of a range dot begin, range dot end, 0 and stirred plus. And what we'll do is we will assert that is equal to 0. And then let's take another one and we'll change that to 1. And then we will pass in a lambda as well. And the lambda can just can be return x. Now I think that clang D is getting in the way here, so let's turn that off.
What is x?
Oh, good point. Thank you. Let's disable this, and we'll throw in an x here and a y here, and just do x plus y. Thank you. Okay, so that is the test. That's all we have to do for now, and we can now go ahead and add a header to libc. So what we'll do is we'll go into the algorithm header in the include directory of the libc directory, and we will add a new file called fold right.h, and that will live just above fold. Now, normally we would put the contents of fold right inside the fold header because that's what it was designed for. However, there's some interesting components in building out a libc header that I would like to talk about, and so we'll just make a fresh file for that purpose. So again, we will just copy the contents up until here and paste that in to save time. We'll close the end if. And then we will also, so lib, cpp, and namespace, followed by an end if. Okay, so there's a fair bit here that we have to walk through. So the first thing is this should be renamed to fold right to make sure that it doesn't clash with the fold header. And we have a bunch of headers that we're gonna gloss over. Those will all be relevant for building out fold right. And then we have this if not defined macro for libcpp has no pragma system header. And this here is basically saying that if you have not defined don't do a system header, then this will be treated as a system header. A system header is something that the compiler will not warn on, even if there are warning-worthy bugs. So usually warnings are our friends, but sometimes warnings can get in the way of implementation-specific things, and because the standard library is a part of the implementation, getting warnings that you didn't write and are done with domain-specific knowledge can actually get in the way of your day-to-day tasks. So we don't want you to be warned wherever possible. But of course, we do like to give you the option of enabling those warnings, and it works very well for testing if those warnings are available as well. So we do have what's called an escape hatch here. The next thing is to push, yes, I forgot to do pop macros as well. Libcpp, pop macros. Okay, so the first thing we do after that is to push some macros. And these macros are macros that clash with some of the standard names. For example, there are a lot of macros for the names min and max, and those clash with stdmin and stdmax, leading to a lot of problems. So what we do is we rely on a compiler extension that allows us to push macros onto a stack, then we undefine them, so that way we can use min and max and so on. There's a variety of headers. Sorry, there's a variety of macros that we just we defer, so that way we don't have to clash with them. And then in this undef macros header, we will undefine them, and then this pop macros will restore them, so that way user code is not at all affected. So that's what that's for. Then the next thing that we do is we open up the namespace std. And the reason that we have this macro instead of just saying namespace std open curly is because this namespace is actually versioned. So libc++, if you ever get a diagnostic from libc++, you usually see std : let me write it out. You'll usually see something like std _1 vector of int and then so on. Something like that. Does that kind of look familiar to folks who've used libc++ and gotten diagnostics? Well, this here is a version part of libc++ of namespace std. I don't know why it's been versioned. I think the intention was to periodically release newer versions of libc++, but we've decided for stability reasons to keep it as just _1. So that's the reason why we do this begin namespace std, because it's just a way of conveniently being able to update everything in a single spot. Are there any questions so far? I don't see any. Oh, yep, one.
Is this C++ CMake?
Yes. Yes, we'll be touching CMake in just a moment, because there is a CMake header file that we have to touch. So the question was, is libc++ a CMake based project? And the answer is yes. Thank you. So the next thing is that the next thing to note is that fold right is a C++23 function, so it can only exist in the we have to section it off for things that are not in C++23. So that's pretty much where things are at right now. Now let's open up the code and get started. So does anyone here besides Tristan know how std ranges fold right is defined? Is it a function? Is it a function object? Is it up to the implementer? Does anyone know that off the top of their heads? Okay, cool. So currently the standard just says that it is an entity. It does not specify whether it's a function or a function object. It just has to be something that you can call like a function. But it's got a very tricky rule about it, in that it doesn't have, it can't be found by ADL, argument dependent lookup, and if it's called in an unqualified situation, then it is not. It is supposed to suppress argument dependent lookup as well. Now we could depend on something in the compiler to do that, but all the major implementations have basically agreed that making these function objects is the way forward. So what we'll do is we will open up a namespace called _fold, and we'll put everything in here. Now, when you see diagnostics to do with the standard library, you probably do wonder so you probably notice and thus eventually wonder why we see things that start with an underscore and why do we have these names with double underscores. How many of you have had that question at some point in your C++ career? Doesn't matter whether you know the answer right now. Just how many of you have had that question at one point? Most hands. Okay. So the reason for that is because the standard reserves very, very few names for for the implementation. It reserves any name that that it exposes. So, for example, fold right is a name that is reserved because it exposes that to the users. It reserves. Sorry, it's reserved in terms of you cannot define a macro, and it also reserves all the keywords, and there may be a handful of other things, like I think POSIX is also a name that you can't define as a macro, but everything else is pretty much fair game. You can define anything else as a macro, to my knowledge. If that is incorrect and someone in the room knows, please let me know. So in order to get around that, the standard does provide two escape hatches. The first escape hatch is any name that starts with an underscore immediately followed by a capital letter. That's a reserved name for the implementation. The second one is that anything that contains a double underscore in its name is also going to be a reserved name for the implementation. And this all has to do with macro. So it's not like we can just open up double underscore fold and then have in here something like struct fold right. That is not going to be okay. We do have to put the double underscores here as well. Are there any questions up until this point? Don't see any questions. Cool. So we do have to have a function called double underscore fold right, and we will name that function, fold right function. And then to get that to be sorry, I forgot to open up a namespace ranges. That was the other thing. Yes. So we have a namespace ranges, and then inside that we have a fold fold namespace, and then we have a fold right function. So it is a little bit nested in here, but that's kind of where things stand. And then to get the fold right algorithm, what we'll do is we'll open up another namespace. There are lots of namespaces in the standard. This one is a reserved namespace called CPO, and it is an inline namespace. Now, the reason for this one, I don't remember off the top of my head, but it is to do with preventing namespace clashes with customization point objects. libc++ has decided that in order to just reduce the complexity, we're going to treat anything that's a function object as a customization point object, regardless of whether or not it is. So in this case, it's not particularly going to have any impact other than simplifying things for people who are defining things in the standard library. What we're going to do is we're going to create an inline object called fold right, which is a fold right function. That's it. That's fold right done. So now let's add some logic here. So inside this structure, we are going to start by going over to the definition, and we can copy this and put this here. And the first thing I like to do is delete all of the concept related stuff, because that is not particularly useful right now. We will come back and re-add all of that during the testing process to make sure that each of those concepts are on the interface. Right now there are no tests, so it isn't really helpful to have them there. And so we're going to make this a callable object. We'll delete the const expert as well because we're not doing const expert testing. And then what we'll do, if I can type correctly, is just return init. And we should delete these, otherwise we'll get warnings. No, that one can stay. And that is it. So that's fold right. Now what we will do is we will close the algorithm header and add this to the CMake file that I alluded to earlier. There is a CMake file that will just copy all of the headers into the CMake, sorry, into the header directory. So we'll find fold, we'll do _algorithm, fold _ right.h. And then finally, we will open up the algorithm header, and we need to include the fold right header in the algorithm header. So let's copy this and place it here. All right, so this should mean that our fold right test will compile and run, and let's see how that goes in a live demonstration on a recorded conference. So to get started, we will we'll first need to configure and build out CMake. What we do here is we'll do a typical component, which is up until this, we'll just create a debug build. What we do differently though is we open up our source in the runtimes directory. So LLVM is an ecosystem of different projects. We have Bolt, we have Clang, we have many, many projects. Then if we go down here, we can see a runtimes directory. And this is home to libc++, libc++ ABI, which are the two C++ standard library components. It's also where the LLVM libc project lives, and the exception handling library known as libunwind, and the compiler built-in library called compiler-RT. The interesting thing here, other than that, is that we're going to enable the runtimes projects. So these are the ones that I just mentioned. And then after that, we will then build out libc++ and then run the tests. So ninja cxx is, ninja cxx -c build, because we need to be in the build directory. And that will build out some stuff. However, it seems as though we have a problem. That is on line 54. And the problem is that I forgot to say that it's in the fold header. So that's it. That's the entire thing done. And so if we now go into the build directory, we can run this tool called bin/LLVM-lit. And so there is a test tool we have called lit, the LLVM integrated test. Yes, sorry, for the people writing things down, I do apologize for all the jargon that I have thrown out today. So the LLVM, lit is an LLVM tool that picks up files and then runs them through a testing framework that then reports things about how the tests went. And it can be configured to have failures, expected passes, unexpected passes. And it really just provides a condensed summary of everything. And then we will pass in two flags, S and V. S is for summary and V is for verbose from memory. So we want a summarized version of the verbose output. And it just turns out that this is the best configuration for the output. And then to speed things up, I will copy the path from here. And then what we'll do is we will just run all of the algorithms. So what we do is we just copy the path from to the directory where the tests live, because otherwise we'd run all the libc++ tests. That would take a couple of minutes, and that would not be a productive use of our time. Even when developing things regularly, don't run all the tests until you're ready to push a PR. Question?
Yeah, so is that simply just looking for the test? Is it like building it now, or is it so that it builds tests? Your test has made yes, I'm building behind executable. So is that actually building and running now, or
okay, that is a great question. Something I did gloss over. So the question was, is this going to build and run the right fold program, or is it going to just run the program? Is that essentially the question? Okay, that is a great question. So when we ran ninja cxx, that built the libc++ library. It didn't build any of the tests, because we don't actually use ctest, the CMake testing framework, for running our tests, that we use lit instead. And so what will happen is lit is essentially a very big Python script, and it will run Clang directly on this, or Clang GCC, depending on which compiler you're testing with, directly on foldwrite.parse.cpp, and it will then run the test after it's been built. Now, something that I didn't mention earlier when we were naming this file is this file is called writefolds.parse.cpp, not just writefolds.cpp. And that was deliberate because lit requires, the libc++ version of lit requires there be this parse in the file's name to communicate that the fold write needs to parse. If we named it fail, then lit would be expecting this test to fail. And there are a few other things. For example, we can say that we want to communicate with the compiler and test the diagnostics that come out. And so there are other ways in which this sort of sub-extension communicates directly with the test framework. Now, let's take a look and see what happens when we run this. So it looks as though something went wrong. This is good. It seems as though this second test, this one here, did not in fact pass. So let's take a look and find out why this is the case. It seems as though all of them failed. So it says here, no matching function call of type fold write. And it turns out that the problem is this here is a const expr object. That means that it is const, but the call operator has not been marked const. And so we actually need to also mark this const. So now what we'll do is we'll rebuild. Every time you make an edit to the fold write header, you also need to rebuild libc++, and the reason for that is because libc++ copies all the files into the build directory and then runs everything from the build directory as if a user was building everything out. So if we just edited the file, it wouldn't have been reflected. So let's try that again. It looks like this passed, which isn't really test-driven development. It should have failed, but in the interest of time, we should probably not do everything like that. Okay, so now let's change these. Let's change this vector to something such as 0, 1, 2, and 3. And so there are now 4 elements. And since these were meant to be just a series of empty things, we should probably change this to begin. And let's now see what happens when we want. Actually, before copying, I should have done this because now I've got to change it back. Okay, so 0, 1, 2, and 3. And so if we sum those up, that is going to be 6. And so we should expect these to all have this one should have the value of 6, this one should have the value of 6, and this one should also, type, has the value of 6. So that's the next thing that we want to do. And so what we'll do is we'll build that out and see what happens just to see if it works. It doesn't work because we haven't made any changes, so let's go and make the changes. So to start off with, let's just write out the naive way of doing this, which is that we're going to go from first through to last. And I was a little bit naughty earlier, and I forgot to rename these. So what we do is in libc++ for types, we name our types in templates as _ capital letter, followed by another letter. We don't ever have single name variables, and that's because there are many macros that are just underscore capital letter, and we are nice and we don't break those because they are typically things that shouldn't be broken and would take a lot of work to clean up. So we typically keep these as f followed by p for parameter, and that will be func. So that one will be TP followed by SP followed by IP. So let's now just do a simple naive. First is not equal to last, followed by plus plus first, and then we will just do a state invoke of the function and start first followed by init. We'll then reassign that to init. This is not actually a right fold yet. This is still a left fold, and it's not even done in the way that left fold is specified. This is more like std accumulate. We'll come back and fix that in a subsequent iteration. Now, does anyone want to guess why we use std invoke instead of just directly calling func? Okay, so the reason is because func is not necessarily going to be a function or a function object. There are also things known as pointers to member objects and pointers to member functions. And those ones, those things are callable, but they are not callable in the same way that regular functions are callable. And that is a bit of a problem. We don't have a unified way of calling all the invocable types, except by using std invoke. That is the way in which we are able to call everything. So what we do is we pass in function to the invoke, and then we also pass in the parameters. Okay, are there any questions up until this point? I see a question.
Is the P convention, or does you use some other second letter?
P is just so the question is P a convention, or can we use some other letter? And the answer is it actually really depends on the situation. So if it's going to be a two-letter identifier, then it's typically just the convention is use a P. However, this one here, IP, is actually not typically named IP anymore. It used to be named IP, but we decided that that for iterators and sentinels, it may be better to name things iter and sent. And in fact, if I was pushing this upstream, they would definitely be called iter and sent because that is what consensus has. I think in the interest of time, we'll keep it as IP, but thank you for asking that question. That was a good point for me to make.
Just go with P.
Just go with P if you're contributing, and if you may get some feedback saying, can you please change to this specific name for other conventional reasons? So, question.
What is the convention to use STL?
Sorry,
What's the convention is to do a phone range or STL?
Or the algorithms. So okay, so the question is, what is the convention here to use a for loop or to use an algorithm? Is that correct? Okay, so because we are defining the algorithm itself, this is a standard library algorithm, we have to use a for loop directly because there isn't really anything that we can depend on right now. We're building out the abstraction itself. Does that answer the question? Cool. Okay, let's do this next one and see what happens. And something has failed. Fantastic. So, turns out that this test has failed which is assertion 0 on std plus from the beginning of the range to the end of the range. Apparently, it is not equal to 6. So there are one of two situations that have gone wrong. Either I don't know how to do simple addition, or I've got a problem in the code. So let's just check. There are 4 elements, and this 1 plus 2 is equal to 3, plus 3 is 6. Okay. Seems as though this one here should be correct. These two, on the other hand, are incorrect. They should be 7. Oops. Okay, so that means that there is a bug in the logic. Let's take a look. We are going from first through to last, and then we're incrementing first. We are going through and assigning a result to an it. We are, we're not starting with init. So if we go back to the definition of a fold right, we can see that what we should be doing is, sorry, not that one. We should be going through and assigning to an accumulator, which I have not done. So let's do that. So we say auto accumulator is equal to std invoke of func, and then first followed by init. And then what we'll do is we will increase first, and we'll assign this to accum and also we need to change this one. And that should fix the issue. I think I know what went wrong earlier. I forgot to copy the headers across after I made the edit. Now we have a different problem. So let's reverse that. Copy the headers back across, and then we'll come back to this problem in a second. Okay, fantastic. So, are there any questions up until this point? Do not see any. Okay, so before we get to that point, there is one other thing that I did want to touch on before we get close to the end. And that is that right now, as we have it, this function is not quite complete from the interface. Was there anyone in the symbols talk this morning? I don't see any hands. Okay, so some homework for all of you is to, once this stuff is on YouTube, to go and watch that talk. What was it called? It was called How Symbols Work and Why We Need Them. Anders gives a good explanation of symbol visibility and why it's a very important part of how shared objects are made. Now, for our purposes, this here is currently being baked into objects as a visible symbol. That means that it is actually going to be baked into the application binary interface, the ABI. And who here is not familiar with an ABI? Okay, cool. Now the problem with doing that is that it makes it difficult for us to change things later on. And so what we need to do is we need to add a macro called libcpp, I believe it's hide from ABI. And that will, if I am correct, yes, that is the name of the macro. That will now make it so that way this has hidden visibility. Hidden visibility does a handful of things. It means that symbols will load a little bit faster. if they're in a shared object, and it will also mean that there won't be, that it reduces the chances of a symbol clash, which is another important thing about having your functions made non-visible or hidden. And then finally, it's no longer considered to be a part of the ABI, and thus we can make changes without this being a problem. Tristan.
This is true even though it's a function template, it's going to be a weak symbol. Hyphen merge it all in time.
So the question was, is this true even though it's a function template? Yeah. Okay, so that's actually a really good question, and I'm not sure I have a good answer to it off the top of my head. I believe the talk this morning did go into it in some detail, but it is at the very least a convention that libc++ does. If there is a function that should not be baked into the ABI, and from memory, I think everything inside namespace std _1 will not be a part of the ABI. Sorry, should not be a part of the ABI if it wasn't already. So we do put this on pretty much everything. Does that answer the question? Cool. I wish I had another answer, and I will in fact fill out on the Discord the answer to that question once I have an answer. Second question.
You have to somehow also hide the type info for your __ all right function.
The question was, do we have to hide the type info for the what? Sorry.
For the struct that this function.
Do we have to hide the type info for this? That is also a really good question. So the question, just to make sure it's fully understood, is do we also need to hide the type info for this? Yep. And the answer is, I believe the namespace, the begin namespace std may also have an attribute on the namespace to do exactly that. Because, wait, no, there is also a struct, sorry, there is also a macro that I'm supposed to be putting here. You were correct. I don't remember what that is called off the top of my head. However, we can cheat, go to fold, and see what that has to say. It looks as though there is nothing here. So one of two things is true. Either I have forgotten to put it on fold left when I implemented that, or we don't need to put it on these sorts of structs. It does have a double underscore in its name, so users shouldn't be relying on that anyway. Does that answer the question? Yeah. Cool. And then normally we would also put a no discard on this, because calling fold right is a thing that that does some sort of computation, and its result is the intended purpose of calling this. libc++ has a suite of tests that that you would go and add. Does fold right have no discard on it? So we would not add that in the interest of test-driven development until we go and add the tests for no discard. And that's similar for the class IP and the class SP and whatnot. In fact, if I was sitting down to do this at my desk in the office, I probably would also take out the iter value t and make sure that that is also being deduced correctly through testing. Basically, I remove, and I don't know, I can't speak for any other libc++ developers in this regard, but when I am sitting down to write out my tests, I will remove all of the defaults that the standard puts in and make sure that that is something that is actively being tested in order to prevent bugs in the future. This is just the way that I get the most confidence that the code that is being written is also being tested. Are there any questions about that? Do not see any questions. Okay, so we should probably make this be a little bit more correct in terms of it being fold right. We haven't actually gotten that far yet. So let's start by taking this, and we'll change it from being just addition to also including subtraction. So minus is, we'll start off with just this, and 0 minus 3 is minus 3, minus 2 is going to make it minus 5, which, sorry, gonna have to write this out. 0, fold right. So we take the rightmost argument and we apply it. Yes, so we have the 3 on this side. We have init on this side. So it will be 3 minus 0, which is equal to 3, followed by 3 minus 2, which is equal to 1, followed by 1 minus 0, which is equal to 1.
2 minus 3.
2 minus 3. Yes, you are correct. 2 minus 3 is. This is why putting working in as sorry. Who was it that spoke? So I can look at you. Is it you? Yep. Cool. So the question was, shouldn't it be 2 minus 3? And the answer is yes. And so when I am writing out the stuff for the fold algorithms in particular. For left fold, I did actually write out all of my working in the initial pass of it. I don't remember if it stayed in the final test, but there was a fair amount of working, and it helped a few of my colleagues just work through everything a little bit faster. So I do hope it stayed there. But 2 minus 3 is minus 1, and then that will turn out to be minus 1 minus 1. If I'm, it's 1 minus 1. 1 minus minus 1. Yeah. Minus 1, which is equal to, yes, 1 plus 1, which is equal to 2. So off by 1 error. Okay, so let's give that a... Sorry? I do need to do the 0. Yes, you are correct. So that will go here, minus 2, which is equal to minus 2. Thank you. Okay. So, are there any questions or concerns with that logic that we've just written out? I do not see any. So let's see if that. We'll start by doing an ninja CXX because that led us to some problems earlier on, and we'll run the fold tests again. And turns out it fails, which is unsurprising. Yes, computer does do the math. That is very important. I haven't said the fold. You're correct. However, the only edit that I made last time was just adding this. So there was for the purposes, I hate what I'm about to say, and most LLVM devs will also hate what I'm about to say, a non-functional change for the purposes of this test. However, yes, you're correct. Thank you for pointing that out as well. So we'll start by adding a couple of checks. So we'll do if first is equal to last, we'll then return init. And I believe that also does the standard, yes, okay. So we will also need to add this. So what this is doing is it is working out what the actual return type of the function is. And the reason we need to do this is because the return type of the function is going to be the common type, effectively, of what operation we're doing. So if you add an int and a double, the result is a double, and that is not necessarily going to be reflected just through init on by itself if init is an integer. So we first need to do this, and then what we'll do is we will make we'll then yes, it is a std move because we are constructing a new object. Normally we would also have a test for building out a move-only object and some input iterators. As I said yesterday, we're only going to get through a part of this. Then what we will do is create a tail. So the tail is going to take us to the end of the range. So we are required to have a bidirectional range because otherwise, sorry, a forward range, otherwise we would have a, if it was just an input range, it would mean that we wouldn't be able to get past everything that we've just seen already. Input ranges don't let us repeat things, but it also has to be a bidirectional range because we need to go backwards. And so then what we're going to do is we're going to take this and we will add it to what we are building out. We'll also uglify it. These are called ugly identifiers just by convention because they have an ugly name with the double underscores. And then we will also decrement from here and change this to tail. So I believe this also needs to change to tail is not equal to first. And this one will need to become a cum. And if I'm not mistaken, that, yes, we do need to do stirred move. Okay, now, we hold our breath. Oh, thank you. And I am returning back to a knit, yes. The dangers of doing a live demonstration. It is like pair programming with 20 people, and I'm very, very happy that that's the case. Now we all know this code is going to be correct. It compiles. Let's see if it runs. Are we going to finish on a high note? Should not be taking this long, so I'm assuming that there is an infinite loop somewhere. Yes, because we should be doing tail. So let's try that again. It fails because this does not pass, which is on line 55. So, sorry, did someone spot the bug? Nope. Okay, so let's see. Should be 1, 2, 3. Have I done something silly? Sorry?
Did you say the file?
I did say the file this time, yes. Let's see, tail, first, last. Then a cum minus star tail is to move init. Yes, first is not equal to tail. A cum f star. Yes, it's done. Okay, I see what the problem is. I have done a conventional for loop, and we need to be doing a minus minus here. Now it should pass. And it passes. Okay, that brings us to the end of the demonstration. To recap, we implemented a part of fold right. Technically, we did finish the logic, but not the tests. There are many, many more tests that we would need to do. Controlling visibility plays a huge role in this. Our practices aren't really different to yours. Normally, we do a lot more tests, but we can only do so much in an hour. And you get used to the ugly names. Please join us. It's not as scary as you think. This is the link to join us. Thank you so much.